Hi there, you are watching a video of API 653 inspection and repair of above ground storage tanks. Let's start introducing the API 653 standard, inspection, repair and alteration of storage tanks. The purpose of the API 653 standard is to provide guidelines for inspection, repair, alteration and reconstruction of above-ground steel storage tanks, which are used in the petroleum, chemical and other industries. The rules given in this standard outline the minimum requirements for maintaining the integrity of above-ground steel storage tanks after they have been put into service. They are based on the knowledge and experience of tanks users, manufacturers, and repair organizations. The standard is organized in 13 sections and 13 annexes, as we can see on the screen. The most important sections are Section 4, Suitability for Service, Section 6, Inspection, Section 9, Tank Repair and Alteration, and Section 10, Dismantling and Reconstruction. And within the annexes, the most important ones are Annex B, Bottom Settlement, Annex C, Inspection Checklists, and Annex F, NDE Summary. Let's describe Section 1, the scope. The scope includes above-ground steel tanks manufactured in accordance with API 650 and its predecessor API 12C. It provides the requirements necessary to maintain the integrity of welded or riveted tanks after they have been put into service, and it covers inspection, repair, alteration, relocation, and reconstruction of these tanks. The scope of the API 653 is limited to the tank foundation, the bottom, the shell, the structure, the roof, ancillary items, and connections up to the face of the first flange, or the first weld joint, or the first threaded joint. Many of the design, welding, testing, and material rules contained in the API 650 standard can be used for the inspection, reconstruction, repair, and alteration of tanks in service. In case of conflict between the requirements of the API 650 and the API 653 for tanks that are or have been put in service, the standard API 653 will be used for tanks that have been operating. The API 653 standard covers the different elements that can be found in a storage tank, such as the roof, shell, bottom, wind girders, stairs, ancillary items, welds, etc. At the same time, it covers and includes the tolerances and verifications need to be made, such as the plumbness, the differential settlement or edge settlement, and the verifications on the foundation. The API 653 standard employs the basic design principles of the API 650 standard. However, it could be applied to the inspection, repair, and alteration of any steel tank built in accordance with the tank specification. At the same time, the standard does not contain rules or guidelines that cover the full range of conditions that can occur with respect to tanks. When design and construction details are not available, the requirements outlined in the most recent version of the API 650 should be used. The standard has been developed for use by organizations that have engineering and inspection personnel who have been trained and have experience in the design, manufacture, repair, construction and inspection of tanks. Ultimately, the tank owner bears the responsibility for compliance with the API 653 standard requirements. Regarding the jurisdiction, if any requirement established in the standard presents a conflict with any local regulation or legislation, the latter will normally prevail. However, if the requirements of the API 653 standard are more stringent than the local regulations and/or legislation, the requirements of API 653 will prevail. Section 2. Reference Standards. Codes and standards are normally referenced to other standards or codes. The API 653 is no exception to that rule, and the reference standards contained are varied and numerous at the same time. On the screen, we can see highlighted in red the most important ones. It is the API RP 580 risk-based inspection, the standard 620 design and construction of large welding and low pressure storage tanks, standard 650 welded tanks for oil storage, API RP 651 cathodic protection of above ground storage tanks, API RP 652 lining of above ground petroleum storage tank bottoms, and API Publication 2201 Safe Hot Tapping Practices in the Petroleum and Petrochemical Industries. Let's talk about definitions. Section 3 of the standard covers all the definitions that need to be taken into account in order to work with the standard. Routine inspection, carried out by plant personnel on a regular basis. External inspection is a formal visual inspection carried out or supervised by an authorized inspector in order to evaluate all external aspects of the tank. Internal inspection is a formal and complete visual inspection performed or supervised by an authorized inspector of all accessible internal components. Repair: any work necessary to return a tank to a condition suitable for safe operation. Repairs include both major repairs and non-major repairs. Examples of non-major repairs are the following: removal and replacement of material, leveling of the shell or roof of the tank, installation or replacement of reinforcement plates, repair of minor flaws. Likewise, examples of major repairs are the following: installing a penetration more than 12 inches nominal pipe size, installing a penetration in the bottom of the tank, removing, replacing or adding plates below the design liquid level, removing or replacing annual plates material, installing a new tank bottom. or removing or replacing part of the shell to bottom joint, raising the tank shell off the foundation. All these are examples of major repairs. All major repairs require a hydrostatic test maintained for at least 24 hours. Two examples of major repairs can be seen on the screen now. On the left, we can see a shell plate, a complete plate, being replaced, and on the right, we can see a manway being installed near the shell to bottom joint of the tank. Alteration. An alteration is any work that changes the physical dimensions or configuration of a tank with respect to its initial design. Relocation. A tank is relocated when it is moved from its initial location to a different one. And reconstruction. Any restoration work on a tank after it has been dismantled. Authorized inspection agency. Any of the following organizations may employ an above-ground inspector licensed by API. Could be an authorized or licensed insurance company, or the owner, operator that maintains an inspection organization for its own plant. At the same time, an independent organization or individual under contract with the operator. Change in service. Changes in operating conditions of stored product, such as temperature, pressure, or specific gravity. Hot tap identifies a procedure for installing a nozzle in the shell of a tank while in service. Corrosion rate. Loss of material due to corrosion divided by the period of time in which this loss occurred. Critical zone. The critical zone is defined as the first 3 inches portion of the tank bottom measured radially from the shell to bottom junction towards the center of the tank. Let's now review a hot tap intervention in an storage tank. First, the neck of the penetration and reinforcement need to be welded to the tank shell. This is going to be the guide and the base for the drilling machine that is going to make a hole in the tank shell while this is in operation. In the picture of the left, it can be seen the drilling machine attached to the added nozzle. After that, the cut of the tank shell is made and the coupon extracted. The critical zone defined before can now be seen on the screen. As you can see, it is a line that is parallel to the shell to bottom joint and separated 3 inches away towards the center of the tank. Let's now go over the most important parts of section 7, materials. This section provides general requirements for selecting materials for repairing, altering, and reconstruction of existing storage tanks. Let's start with new materials. All new materials used in repairing, altering, or reconstruction of tanks, including accessories, must be in accordance with the current applicable standard. Section B covers original materials for rebuilt tanks. All shell and bottom plates welded to the shell must be identified. Materials that are identified in the original contract drawings, API nameplates, or other appropriate documentation do not require further identification. However, materials that are not identified will be subjected to chemical analysis and mechanical tests in accordance with applicable norms and specifications. Once the material is identified, it can be determined if it is suitable for service or not. Regarding roof, bottom and plate wind girders, if existing plates are used to rebuild the tank, checks for excessive corrosion, small cracks and pitting are needed. The requirements are indicated in sections 4 through 6 of the API 653 standard. Let's now review section 8, Design Considerations for Reconstructed Storage Tanks. The tank owner-operator should specify any special design considerations, beyond the normal ones related to the intended service, that apply to rebuilding a tank. For example, storage tank shell design. Shell thickness measurements to verify the design must be made within 180 days prior to the relocation of any tank. The maximum liquid level must be calculated for each shell course according to the following: the level based on specific gravity of the product, the actual thickness measured for each shell course, the maximum allowable stress for each shell course, and the design method to be used. The allowable stress for the material must be determined using API 650, tables 5.2a and 5.2b. And for the hydrostatic test, the liquid level is calculated in a similar way as that indicated for materials that are not listed in table 5.2a and 5.2b of the API 650 standard. One of the fundamental aspects of any storage tank shell design is the joint efficiency. The joint efficiency and the maximal allowable stress must be consistent with the design method used and the degree and type of examination made on welded joints we are regarding to the original construction. In the case of existing joints that will not be eliminated or replaced, the original values used for the design must be maintained. As for wind girders and shell stability, the upper and intermediate wind girders must be in accordance with the current applicable standard. Wind-induced buckling should be checked for compliance with the current applicable standard with the wind requirements at the site where the tank will be rebuilt. Likewise, seismic design must be verified. This is covered in Annex E of the API 650. Seismic stability will be verified based on the guidelines from the current applicable standard, using the dimensions and thicknesses of the reconstructed tank. The seismic stability assessment may indicate that thicker bottom plates or even anchors are now required, even though they were not previously required. Section 11. Welding. Let's talk about welding qualifications. Welding procedure specifications (WPS), welders and welding operators must be qualified in accordance with ASME Section 9, as well as the additional requirements of API 650, Section 9, and API 653. As you can see, in order to fully determine the welding qualifications, you need to be jumping from one standard or code to the other. The weldability of steel in existing tanks must be verified. If the material specification for the existing steel tank is unknown or outdated, test coupons for the welding procedure qualification (WPQ) will be taken from the actual plate of the tank to be used. Identification and records. Each welder and welding operator will be assigned an identification number, letter, or symbol. The records of this identification, together with the date of the results of the welder's qualification tests, must be available to the inspector. The welder or welding operator's identification mark shall be hand or machine stamped at intervals not greater than 1 meter, 3 feet, along the completed welds.